sets of ordered pairs. So basically set 1 contains 2 points, 1, 5, and 2, 5, and set 2 contains 2 points, 5, 1, and 5, 2. And the question, this is an important question for the beginning of what it means to be a function, okay? So this was purposely designed to start you to think about the definition of what it means to be a function, which we'll be talking about for the rest of the class, and every math class you take after this point will deal with functions. So in which set is the x coordinate paired with one and only one y coordinate? Which set? The first set, right. Okay, so the first set, the x coordinate 1 is paired with 5, no other number, and it happens to be that 2 is also paired with 5, but that's okay. So here, if you know your x coordinate, you know your y. There's no debate. However, now we come down to set 2, and we have a very confused number 5, because 5 doesn't know who to be. 5 doesn't know to be 1 or am I 2? Okay, maybe this is what they call those multiple personalities, right? We can't, 5 has to know its true identity. And it can be the identity of somebody else. Everybody could have the same identity, but 5 can't have 2 different identities. So this idea is one of the ideas we're going to be talking about more in the next 2 days. So set 1 would be the correct answer here. Okay, so here we're just trying to get you again to review linear functions. The first function is a line 2x with a slope of 2, and it goes through 0, 0. So if it goes through 0, 0, the next point when x is 1 is going to be 2, and then it's just going to, for every jump of 1, it's going to jump up 2 from there. And then similarly, when we go down 1, we go to -1, -2, and -3. Oh, did I scoop? Yeah, I missed that one. Oops. All right, so sorry, folks, my eyes are off here. So the scales are off. So there's y equals 2x. And here you should have -4, -2, 2, 4, 2, what am I doing here? 2, 0, 2, 4, yep, 0, 2, 4, okay. Okay, if nobody has ever showed you this before, let me point out that if you're looking at a table, and I'm just going to take this table and, where's my camera over here? I'll just put this on a new page for a second. If you're looking at a table like this, and someone says to you, is this a linear function? There's always a way to know. A linear function, as we know, will have a constant slope. And what that means is that for equal changes in x, y grows by the same constant amount. So since this table is set up for all these x's to be, the change in x here to be increasing by 1, from -2 to -1 is an increase of 1, from -1 to 0 is an increase of 1, 0 to 1. So these have equal differences in my x value. They're all 1. And then if you notice here, my y is increasing by 2. So this is what we call first differences are constant. Your first differences are constant. And whenever your first differences are constant, that just means I'm taking successive y values and subtracting them, and I get the same constant all the way down, and I'm looking at the same changes in x, whatever it could be. I could have gone from -2 to 0 and 0 to 2 if I wanted and have it be changes of 2 in x, but it's just set up this way. Whenever your first difference is a constant, then you know your equation is linear or your function is linear. So you might say, when would this not be true? So let me just show you another situation. Let's put in a blank page. Just give me a table over here. Yeah, let's do a 1. Let's do by 2. We'll do a couple of those. Okay. So let's say here's our x value. Here's my x values, and here's my y values. Okay. So let's do the same thing. We're going to do -2, -1, 0, 1, 2, 3. Okay. And now I'm going to do this. And you might even recognize what the function is just from the values I'm putting in here, or what the equation would be. Does anybody notice what that is? Y equals what? X squared. So this is y equals x squared, but we're just going to know this like a little birdie told us, right? Told us that y equals x squared. It was actually Mahendra, but he'll be our little birdie. And you know that that's not a straight line. So let's see how you can tell it's not a straight line, and how you can tell that it's a second degree or a quadratic or a parabola. So you do the same things. You look at the successive differences. Here your change in x is getting bigger by 1 as you go from -2 to -1. And that's constant and the same all the way along this table, so that's good. And now let's look at our differences in the y's. What's happening with the y here? This is going down by 3. This is going down by 1. This is going up by 1. This is going up by 3. That's going up by 5. In fact, we don't even need that last one. Let's just keep it symmetric for now. Okay. Okay, so you say the first differences are not the same, are they? For all my change in x is all 1, but notice these numbers are not the same. Can't be a straight line, because my change in y over change in x is not a constant. However, do second differences. Go out one more time. Second differences means you're looking at what's happening with these numbers, your first differences. So what happens as you go from -3 to -1? Are you getting bigger or smaller? No, -3 to -1. How are you moving on your number line? You're going from left to right. So you're increasing by 2. So here you change. So here were your first changes, first differences. Here's your second. And what is it? It's 2, right? From -3 to -1 is 2. What about -1 to +1? 2. What about 1 to 3? 2. So whenever your second differences are constant, then you know you have a parabola. You have a quadratic relationship. Okay? What would you suspect if I did y to the third power? How many times would I have to go out to see a constant? 3. Okay? So that's just a little added feature since we have a little extra time today. All right. So the next graph is going to look in fact, if I asked you to tell me something about these two graphs before you even graphed them, if you know this, could you tell me something about the two lines before you even graph them? They're parallel. And how do you know that? The same slope. So notice both of these lines are increasing and decreasing at exactly the same rate. The only difference is this first one goes through 0, 0, and your second one goes through 0, 4. So all it tells me is that this line, y2, is going to look exactly like the pink line, except for every single y value. Instead of here, my point is 0, 0. Now my new point will be 0, 4. My y value is just stepping up a little bit by 4 steps. My x values are staying exactly the same, but my y values are all getting bigger. Because look, do you agree that I could write y2 like this? y1 plus 4? Does everybody see what I did? I just substituted. 2x is the same thing as y1. So to make y2, it's y1, whatever I get, and I add 4 to it. So everything here looks identical, except, I think I missed something again. I did 2. It's really hard sometimes looking at this. So this is 1, 1, 2. So it should be 1, 6. Oh, I should be up 1. There we go. Yeah, you know when you come up here, it doesn't look as, so it should be 1, 6. And this is what? 2, 4. So it should go up to 8. And this is 3, 3, 6. So it should go up to 10, which is here. So there we go. All right. So you notice this graph is parallel, but all the y steps are up by 4. So this has to do with material next week. This is what we call transformations. And we're going to spend 3 days on this, so you can imagine how important it is. 3 days on transformations. This is introducing us to the basic concept of what a function is, which we'll cover more. And now we've got this exercise here to do, which is also going to cover 2 very important ideas that we're going to use again the whole semester to talk about. It's one of the ideas is domain, and the other idea is range. That's what we're getting at here. And what you can see is that we haven't done any formal definitions of anything yet. However, you're able to actually proceed a little bit and sort of get some answers here that make sense to you. Now, if I asked you, and Spencer, I'll call on you if nobody can come up with it. If I asked you what function was, what was being graphed here, what equation, would you be able to tell me? All right, half of that's right. Absolute value of x, part of that is right, because what would the absolute value of x look like? That would look like this. Right, here we go. Be careful with the square part. So here's the absolute value of x. We saw this in our second class notes when we defined it, or maybe it was actually the first day. Oh, brother, Linda. I'm really off today with my graphs. Look at this. All right. I should have had a day off. Well, I think it would help if I actually started sleeping. Sleeping always helps one. Yeah. Okay. So in the last 2 nights, I've slept in 2 nights a grand total of about 7 hours. Okay, there we go. So this pink graph is the absolute value of x, right? So if we just take in mind really the same idea, oh, I actually made a mistake on that one, Spencer. We actually think of the same idea that this green line and this pink line have exactly the same form, except for everything on the green line boosted up by 4, right? And we see that the only difference in the equations is that we add 4 to all the y values. What could you tell me about the red line and the blue line? What's their relationship? Yeah, the blue line, all the output values, which we've been traditionally calling our y values, are just up 1 unit. So the equation for our second, let's call this y1, the pink one y1, and the blue one y2, is just that first absolute value, and then you add 1 to all the outputs. There you go. Okay, that's neither here or there. I didn't expect you to know that. All right. So what is the y coordinate when the x coordinate is 2? The y coordinate is 3. And that's a point on your graph right there. It's 2, 3. What are the x coordinates when the y coordinate is 4? So how would you figure that out when the y coordinate is 4? How would you actually get that? Just from the graph without knowing the equation, how would you find that answer? What are the x coordinates when the y coordinate is 4? What did you do at your seats? Look at x's on both sides. Yeah, there's going to be 2 answers. And how would you use your graph to find that? Where do you go on your graph? Find where y equals 4. What kind of line is y equals 4, folks? Yeah, all lines are straight. I love that answer. I get it all the time. What kind of line is y equals 4? Horizontal. Thank you. So if you draw a horizontal line straight through our absolute value graph here that we just figured out, notice it hits in 2 spots where y is 4. And the x values that give you that are negative 3, 4, and positive 3, 4. Okay. negative 3, 4, and positive 3, 4. So the x values that, the x coordinates that give you a y coordinate of 4, notice there's 2 of them. So this is like going back to the very first question. It's okay for negative 3 to go to 4 and for positive 3 to go to 4. It's okay, because if I'm negative 3, I know my identity, it's 4. If I'm positive 3, I know my identity, it's 4. Okay, so now this next one, this, I want you to make some notes. This involves the idea of domain, which we're going to use over and over again, and this involves the idea of range. Okay, so let me erase this. Okay. Oh, I didn't want to erase that. Wow, that was, I just want to get the line out of the way. Bring it down here. Okay, so this first question says, use interval notation to describe the set, because an interval will describe a set of numbers that contain all the x coordinates of the points on the graph. Well, if this graph stopped here and here, right? If the graph stopped right here, then my set of numbers would go from, say, negative 6 to positive 6, all right? It would stop. However, these arrows indicate what? It goes on and on forever, which means that this horizontal axis, what? Goes on and on forever in both directions. So that means that the set of numbers would be this entire number line, the entire thing as far as I can draw it, okay, in both directions. Okay, so that means the set of x coordinates is all real numbers, all of them. There's no limit on there what I can put in for x. I can take the absolute value of any real number and add 1 to it. So the interval notation would be parentheses negative infinity, comma, infinity. Okay. And this is what we call the domain of our, and I'm going to use the word function, even though we haven't defined it yet. It's the set of all possible x values in this case, it's a set of all possible x values that makes sense here. That makes sense. That means when I say that makes sense, this is not a mathematical definition of domain, but by making sense, meaning I can come out with an output. If you give me any x value, I can go up to the graph. It makes sense because there's a value that's associated with that x value. It has meaning. It can be defined. It can be represented as a quantity called the output. All right. So that's the domain. Oops, I wrote it in the wrong spot. No, I just wrote these two things in the wrong spot. This is domain here. This is domain. Get back to blue. And now range. So range says, use interval notation to describe the set that contains all y coordinates. So let's look at our graph here. Well, y coordinates, that would be any point along here. And if I kind of came over here, from here, I'd say, oh yeah, that I'd be right along here. I'd be kind of coming right over in this direction to my y axis. All right. So where do my y values begin? What's my smallest y value here? 1. So that means the set of all outputs, or the set of all y values, would start at 1 and go up to the heavens, because there's nothing stopping this thing. Nothing. So this one would go from 1 right here all the way up forever and ever to positive infinity. And that's called the range. So the range has to do with the set of all possible output values, or what you've been calling y values, and the domain has to deal with the set of all input values. Okay. So that's the preview activities. So one of the things I've decided today is, since my first class did not meet, I'm going to create a video of the preview activities only and ask my first class to do the preview activities. And on Friday, both classes will start with the demo for class 11. And what do you